See, if depending on the RHS, we have to do a decision. Prove this as ABC into 1 plus 1 by A plus 1 by B plus 1 by C. Practice this problem, one of the important problems. Common operations, if you use that, the process becomes simple. If product of 3 terms is 0, then each term is also 0. So, depending on RHS, you have to do transformation. If you see, every element of a row is jumbled. XPQ, here PQX, here PQX. Common operation I am doing. Why? Because it reduces your time and thinking process. Welcome to the session, dear students. In my last class, we have done few problems based on properties of determinants. In today's class, we'll go ahead with some more problems based on properties of determinants. So now, we'll start with a problem like this. They want you to prove 1 plus A, 1, 1, 1, 1 plus B, 1, 1, 1, 1 plus A is equal to ABC into 1 plus 1 by A plus 1 by B plus 1 by C. See, if depending on the RHS, we have to do a decision. Here you can see A, B, C as common and 1 plus 1 by A, 1 by B, 1 by C. Here you don't have any reciprocals. What we can do? So decision depends on what is RHS. RHS na correct observe madadre 1 by A, 1 by B, 1 by C ide. So I have to get 1 by A, 1 by B, 1 by C. But here in LHS we don't have that. So that's why what we do, we'll take LHS. That is 1 plus A, 1, 1, 1, 1 plus B, 1, 1, 1, 1 plus C. I have taken this. Now what I will do is, to get 1 by A, 1 by B, 1 by C, I will take common. So now taking A, comma B, comma C common from R1, comma R2 and R3 respectively. R3 respectively. If I do that, so A, if I take common from first row, it will become, here we don't have A, so it will become 1 by A plus 1, and this term becomes 1 by A, and this will become 1 by A. Similarly, from second row I am taking B out. So here there is no B illa, so it will become 1 by B. Now here also we don't have B, so if I take B common, it will become 1 by B plus 1. And here I am taking B from this, so it will become 1 by B. And from last row you take C common. From last row take C common. If you take C common, it will become 1 by C, 1 by C, and 1 by C plus 1. Now observe all the elements. See, in one column if you see 1 plus A 1, 1 by B, 1 by C. So now simple, R1 dash is equal to R1 plus R2 plus R3. For first row I will add second and third row. How to add the rows? Add the corresponding elements. If I add the corresponding elements, I will get A, B, C into, for this I will add this and this. So it will become 1 by A plus 1 plus 1 by B plus 1. So it will become 1 plus 1 by A plus 1 by B plus 1 by C. Similarly, this and this if I add, I will get 1 plus 1 by A plus 1 by B plus 1 by C. Similarly, these three if I add, I will get 1 plus 1 by A plus 1 by B plus 1 by C. And the other columns will not disturb. What are the other rows? 1 by B, 1 plus 1 by B, 1 by B, then 1 by C, 1 by C, 1 plus 1 by C. I will write as it is. I hope till this part you got this. Next. So now A, B, C into first row we have 1 plus 1 by A plus 1 by B plus 1 by C. Every element is 1 plus 1 by A plus 1 by B plus 1 by C. Third element is also 1 plus 1 by A plus 1 by B plus 1 by C. So now second and third row were different. Observe, second row 1 by B, 1 plus 1 by B, 1 by B. 1 by B, 1 plus 1 by B, 1 by B. Third row 1 by C, 1 by C, 1 by C, 1 by C, 1 plus 1 by C. Now from first row what you can take common? ABC into, from first row I will take 1 plus 1 by A plus 1 by B plus 1 by C. And if I take that I will be left out with 1 1 1, 1 by B, 1 plus 1 by B, 1 by C, then 1 by C, 1 by C, 1 plus 1 by C. Now perform column transformation or subtract, then you expand, you will get the answer. So now further what I can do, I'll do C1 dash or C2 dash is C2 minus C1 and C3 dash is C3 minus C1. Outside we have ABC and inside C2 dash, first column I am not disturbing, 1 by B, 1 by C, and this C2 dash is C2 minus C1. So in these two if I subtract, this will become 0, 1 plus 1 by B minus 1 by B becomes 1, and these two if I subtract I will get 0. Similarly these two if I subtract, 1 minus 1 is 0, further 1 by C minus 1 by B, further 1 plus 1 by C minus 1 by C becomes 1. Now expand this, you know how to expand this. ABC into 1 plus 1 by A plus 1 by B plus 1 by C already out. So this, now we will write ABC into 1 plus 1 by A plus 1 by B plus 1 by C, and 1 into, delete the column and delete the row, you will get 1 into 1 is 1 and 0 into anything is 0, you will get 1 minus 0. So we got the RHS. ABC into 1 plus 1 by A plus 1 by B plus 1 by C. That's it. This is the RHS. It's a very interesting problem. In order to solve this problem, first you have to think what is the best method. So first they gave this 1 plus A, 1 1, 1 1 by 1 plus B, 1 1 1 1 plus C. You should prove this as ABC into 1 plus 1 by A plus 1 by B plus 1 by C. First we will take LHS. When I observe I want ABC common. So what I will do, I will take A, B, C common from first row, second row and third row. A common from first row, B common from second row, C common from third row. When I take A common from first row, here you can see in first row we do not have A. So but from this if I take A common, this will become 1 by A, and this A is out, so it will become 1. Here we do not have A. If you take A common, it will become 1 by A. From here we do not have A. If you take A common, it will become 1 by A. Same thing we have done. Then we will add R1 plus R2 plus R3. For first row we will add second row and third row. You know, equimultiples of any rows you can add to the any row. So I have done R1 dash is R1 plus R2 plus R3. New value of first row is sum of all three. So corresponding elements if you add, you will get the first row same. What you will get? 1 plus 1 by A plus 1 by B plus 1 by C. Each element in first row becomes 1 plus 1 by A plus 1 by B plus 1 by C. Since each element in the first row is same, you can take common. If you take common, 1 plus 1 by A plus 1 by B plus 1 by C, if you take common, will be left out with 1 1 1. And I told you, if you have 1 1 1, make these two zeros, and C2 dash is C2 minus C1, C3 dash is C3 minus C1. And if you do that, whatever the remaining part, if you expand, only one element, because these two are zeros. So expand with respect to this, you will get 1 into ABC into 1 plus 1 by A plus 1 by B plus 1 by C becomes this. That is the RHS. I hope all of you got this. Practice this problem, one of the important problems. Further, they are asking you to solve for x. They are not asking you to prove. Please read this problem carefully. They want you to solve for x. What is meant by solve for x? Solve for x means find the value of x. What is meant by solve for x? Find the value of x. So they gave determinant of this is 0. They have given determinant is 0, you need to find the x value. So for that, how to solve this? We will take expansion, that is plus minus plus, expand it. Like that we need to do. But please understand, we can solve this by simple technique. Normal method is expansion, but if you expand, you will get a big equation. So instead of that, reduce it. How to reduce this? Observation. Observe and use the properties. X plus 1, x plus 2, 3. Every row, same elements jumbled. So what I will do? I will do C1 dash is equal to C1 plus C2 plus C3. For first column I am adding second and third column. If I do that, means I will add this and this. What is x plus x? 2x. 1 plus 2, 3. 3 plus 3, 6. So I will get 2x plus 6. Again x plus x is 2x, 2 plus 1 is 3, 3 plus 3 is 6. Every element in the first column becomes 2x plus 6 if you observe. Then second column you retain. What is second column? X plus 2, x plus 2, 2. Third column you retain, that is 3, x plus 1, x plus 2 is equal to 0. Now we observe the first column. In first column, what is common? 2x plus 6 is common. So taking 2x plus 6 common from column 1, common from C1. If you take from column 1, if you take common, we will get 2x plus 6 into 1, 1, 1, and remaining, that is x plus 2, you write as it is, that is x plus 2, then we have x plus 2, 2, then 3 x plus 1, x plus 2 equal to 0. You know how to expand this? I told you always, if you have 1, 1, 1 down, you can do R2 dash is implies R2 minus R1, and R3 dash is R3 minus R1. Always I told this is a better method. Second row minus first row, third row means remove the common row. If 1, 1, 1, if you have, this is a better operation, remember this. And if you have 1, 1, 1 horizontally, in a row if you have 1, 1, 1, you can do C2 dash is C2 minus C1 and C3 dash is C3 minus C1. That's what we have done to reduce. Or any property or any transformation you can use which is mathematically correct. Now R1, R2 dash is means this I am making this. So first row I am not disturbing, first row let it be as it is. R2 dash is R2 minus R1. So 1 minus 1 is 0. X plus 2 minus x plus 2 is 0 again. X plus 1 minus 3 is x minus 2. And R2 dash, R3 dash is R3 minus R1. R3 minus R1, I will do this too. So here see R2 dash, R2 minus R1, 1 minus 1, this minus this, x plus 1 minus this. Similarly, these two if I subtract, 1 minus 1 is 0, 2 minus x plus 2 if I do, it will become minus x. Then third, x plus 2 minus 3 if I do, I will get x minus 1. X plus 2 minus 3 becomes x minus 1 is equal to 0. Now expand this, we will get the answer 1, 0, 0, x plus 2, 0 minus x. So I will write this here, 2x plus 6 is one term and determinant of 1, 0, 0 we have, then x plus 2, 0 minus x, then we have third column, that is 3 x minus 2 x minus 1, 3 x minus 2 x minus 1 is equal to 0 they told. If product of two terms is 0, then each term is 0, equate it. So 2x plus 6 is 0, 2x is minus 6 or x is minus 6 by 2, one of the value of x is minus 3. Now this term equate it to 0, that is determinant of, expand this, if I expand this, plus minus plus, so I equated this to 0 because product of two terms is 0 means each term is 0, I got one x, that is minus 3. I'll expand this and I'll equate it. You know how to expand this. If I expand this 1 into, delete this, it will become 0 minus, minus of minus becomes plus x into x minus 2 plus minus x plus 2 into, that's it, only one element because these two are zeros, is equal to 0. Simplify this, you will get x into x minus 2 is equal to 0. Further simplify, x is equal to 0 and x is equal to 2. That's it, 3 values. I hope all of you understood this. First I equated this to 0, then I expanded this. If I expand only one element, you will get 1 into delete this, you will get that set. And further you don't need to expand because if two elements are 0, only with one element you will get R. Further if you expand also, you get zeros. After expansion you will have only this part, that you equate it to 0. X into x minus 2 is 0. So x is also 0, x minus 2 is 0 means x is equal to 2. 3 values for x. I hope all of you understood this. Let me explain this again. If you observe 2x plus 6 and expand this, I am asking you, if you expand this, you will have 1 into, delete the row, delete the column, you will have 0 into anything, 0 minus, these two if you multiply, minus into minus is plus, x into x minus 2, and further don't expand with this and this, it will give 0. If you check, delete this and delete this, you will get 0 into anything 0, 0 into anything 0, 0 minus 0 is 0, like that. So now further you simplify, this is equal to 0 we have. So 2x plus 6 into This 0 plus this is same, x minus 2 equal to 0. Now product of 3 terms is 0. If product of 3 terms is 0, each term is 0. First I will equate 2x plus 6 to 0, then I will equate this x to 0, then I will equate x minus 2 to 0. I will get 3 values of x. This will give x is equal to minus 6 by 2, this will give x is equal to 0, this will give x is equal to 2. So now x is minus 3, x is 0, x is 2. So now we got 3 values for x. Minus 3, 0 and 2. I hope all of you understood how to solve. Similarly, we have many more problems where they'll ask you to solve. Solve means what? Find the value of x. Now, again if you observe, they're asking you to solve. Again you observe, elements in each row are same. 3, 3, 3x minus 8, 3, 3, 3x minus 8, 3, 3, 3x minus 8. ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸು ಸೇಮ್ ಇದೆ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಒಂದು ರೋ ಅಲ್ಲಿ ಇರೋ ಎಲಿಮೆಂಟ್ಸ್ ಎಲ್ಲ ಸೇಮ್, ಜಂಬಲ್ ಆಗಿದೆ. ಫಸ್ಟ್ ರೋ ಎಲಿಮೆಂಟ್ಸು 3x minus 8, 3, 3. Second row also we have same, but 3 and 3 are jumbled, their positions are jumbled. The row elements are same, but they are jumbled. So I can again perform what? C1 dash is equal to C1 plus C2 plus C3 ಮಾಡಿದ್ರೆ problem simplifies. ಇದು ಮೂರನ್ನು ಆ್ಯಡ್ ಮಾಡಿ, ಇದಕ್ಕೆ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? 3x will be as it is, minus 8 plus 3 plus 3, minus 8 plus 3 is minus 5, minus 5 plus 3 is minus 2. So it will become 3x minus 2. This will also become 3x minus 2. This will also become 3x minus 2. Second column don't disturb, that is 3 into 3x minus 8, 3, 3x minus 8. Determinant is 0. Now what is common in first column? In first column we have 3x minus 2, take common. Taking 3x minus 2 common from first column. If you do that, you will get 3x minus 2 common, 1, 1, 1, then 3, 3, 3x minus 8, 3, 3, 3x minus 8 is equal to what? 0 they give. Now expand this. I told you, if you have 1, 1, 1 like this, common thing is what? ಇದನ್ನು 0 ಮಾಡಿ, ಇದನ್ನು 0 ಮಾಡಿ, like last problem. R2 dash is R2 minus R1. I'll always use same row transformation so that you can remember. It's not necessary you have to use same. R3 dash, what is R3 dash? Again common, R3 minus R1. So problem gets reduced faster. So now 3x minus 2 into R2 minus first row we are not disturbing. First row 1, 3, 3. Second row is what? Second row minus first row. This minus this, if you do 1 minus 1, 0. 3x minus 8 minus 3 becomes 3x minus 11. 3 minus 3 becomes 0. Now I will subtract these two. If I do 1 minus 1, 0. 3 minus 3 is 0. And 3x minus 8 minus 3, 3x minus 11 is equal to 0. Please observe, below the diagonal all the elements are zeros. If you want to expand, this is product of diagonal, that's it. Further, we have 3x minus 2 into 3x minus 2 into first row. After doing the operation, we have first row 1, 3, 3, 1, 3, 3. Second row 0, 3x minus 11, 0, 0, 3x minus 11, 0. Third row what we got? 0, 0, 3x minus 11. 0, 0, 3x minus 11 is equal to 0. Now expansion is simple. So that implies this 3x minus 2 will be as it is. Expansion is simple. Below the diagonal all are zeros. Below the diagonal or above diagonal, if all the elements are zeros, then the value of determinant is product of diagonals. If you expand, you will get same. So by expanding 1 into, you will get these two, that's it. These 3, if you multiply 1 into 3x minus 11 into 3x minus 11, that's it, is equal to 0. I am repeating, you expand this, 1 into delete this into this minus 0, that's it. Or simple hint I am giving you, by expanding you will get only product of diagonal elements, because below diagonal all are zeros. Remember, if below diagonal all are zeros or above diagonal all are zeros, then the value of determinant is product of the diagonal elements. So that is, or we will say expanding. If you expand also you will get same. Now see, product of 3 terms is 0. So now we got 3x minus 2 into 3x minus 11 into 3x minus 11 is equal to 0. We got product of 3 terms 0. If product of 3 terms is 0, then each term is also 0. So now 3x minus 2 is 0. So 3x is equal to 2, or x is 2 by 3. Similarly, second term 3x minus 11 equal to 0. So, x is 11 by 3. So, 2 values, and third term is same repeated factor. The factor is repeated, so root will repeat. So, 2 different values of x, 2 by 3, 11 by 3. So, solving means what? Finding the value of x, and we found out using the properties of determinants. I hope all of you understood this. So, if 2 problems I have done, now this is a third problem. Second and third problem we have done common operations, C1 dash is C1 plus C2 plus C3, because when you observe in a row elements are jumbled. If you add, you will get same element and take it common. Then 1 1 1, if you get C2 dash is C2 minus C1, C3 dash is C3 minus C1, makes your process faster. Then same technique you can use here. They are asking you to prove x minus y. Observe this problem. To solve this problem, first you observe RHS. In RHS you have x minus y, y minus z, z minus x. If I want x minus y, x is here, y is here. X is in second row, y is in first row. So that's why if I want, we'll take LHS and we'll take a decision depending on RHS. In RHS, x minus y, y minus z is there. So what I'll do, R2 dash is R2 minus R1. R3 dash is R3 minus R1, R2 I'll do. At a time you can do 2 operations, we have done it. So first row we are not disturbing. First row is y plus z, y square plus z square, let it be. And second row minus first row, this minus this if you do 0. And this minus this if you do z cancels, it will become x minus y. And this will become z square cancels, it will become x square minus y square. Further, these two if you subtract, 1 minus 1 is 0. Here x cancels, you will get y minus z. Here x square cancels, it will become y square minus z square. Now further, if you observe, in the second row I can take x minus y common. Let me write this as 1 y plus z, y square plus z square, then 0 x minus y. Can I write x square minus y square? What is a square minus b square? A plus b into a minus b. I'll write x square minus y square as x plus y into x minus y. Then last 0 y minus z, y square minus z square, I can write it as y plus z into y minus z. Now already we have, now we need to expand. So I'll take, see if you see the second row, what is common? X minus y. Third row y minus z is common. So here second row only x minus y the x minus y they can take. So now taking x minus y common from second row and y minus z, I'll take y minus z common from third row. If you do that, so take x minus out and take y minus z out, then you will be left out with 1 y plus z, y square plus z square, 0, this will become 1, this will become x plus y, again this is 0, y minus z is out, this is 1, this will become y plus z. Now expand it, you will get the RHS. So x minus y, y minus z, 1 0 0. So now we will expand this. So we had x minus y was out, y minus z was out, and we had 1 0 0, we had 1 0 0, and what is the second column? Y plus z 1 1, y plus z 1 1, and third row, what is the third row? Here we had y plus z, get rid of x plus y. So now we copied this, now we expand this. Only one element to expand, because the remaining two, in any column, if leading element is there and the other two are zeros, expand with respect to that, that's it. So now x minus y into y minus z into expand. 1 into delete the row, delete the column, you know 1 into y plus z. What is 1 into y plus z? Y plus z minus multiply x plus y. 1 into x plus y is x plus y, but in between minus is there, use brackets, and that's it. Y plus z into everything becomes 0. Further solve. expand this, so it will become y plus z minus x minus y. So plus y minus y cancels, so we are left out with what? X minus y, y minus z, z minus x. This is the RHS. This is the RHS. If you observe, we got the proof. See here, if you see the problem, they gave 1 1 1 y plus z, y square plus z square, but observe x minus y unit, y minus z, z minus x. X minus y means and y are here, x, y and z are here. Depending on that, decide this operation, you will get the answer. So depending on RHS, you have to do transformation. So I observed x minus y. So if I want x minus y, what I should do? R2 minus R1. R3 minus R2 gives me y minus z. So at a time you can do two operations. We have done and we got the answer. Now here what we have? X minus p. Then we have x minus q. So at a time you can go get x minus p and x minus q. See, x is in first column, p is in second column. So what is the operation? C1 dash is C1 minus C2. Similarly, I want x minus q, this minus this. So I will write, here also we have x minus q, here also we have x minus q, here also. Or one more simple interesting thing you can observe. What you can see here? X plus p plus q. First I wanted to I decided to do this, but when I observed the third term is interesting. Third term is what? X plus p plus q. If you see, every element of a row is jumbled, x p q, here pqx, here pqx. So what I can do? Simple. I will do c1 plus c1 dash is c1 plus c2 plus c3. I am adding all the elements to first column. If I do that, x plus p plus q, this will also be, second element also becomes x plus p plus q, third element also becomes x plus p plus q. Then remaining I will write as it is, that is pxq, qqx. What is common? X plus p plus q is common. Taking x plus p plus q common from C1. From first column, take x plus p plus q out. If you do that, what you will have? X plus p plus q, if I take out, I will be left out with 1 1 1, and remaining what we have? pq, xq, q minus qx. That's it. Now I told you, see 1 1 1 is there, so I will do R2 dash is R2 minus R1. R3 dash is, I will not even see the elements. Whenever I have 1 1 1, this is the best method. R3 dash is R3 minus R1. R3 minus R1. If I do that, outside already we have x plus p plus q. So first row retain, first row let it be 1pq. Second row becomes what? Second row minus first row. If you subtract, it will become 0. This will become x minus p. This will become 0. Similarly, third row is third row minus first row. 1 minus 1 is 0. Q minus p. And then x minus q. Now expand this. If you expand this, you will get x plus p plus q into 1 into, deleting this, you will get x minus p into x minus q minus 0 into anything is 0. So finally you got x plus p plus q into x minus p into x minus q equal to 0. Hence the proof. Interesting. When I observed x plus p plus q, same x p q are in each row. Here you have x p q, here you have x p q, here we have x p q, but they are jumbled. So C1 dash is equal to C1 plus C2 plus C3 makes every element of the first column as x plus p plus q. Take it out, common, then it becomes 1 1 1. When it is 1 1 1, I am repeating common operations. If you use that, the process becomes simple. Okay, let me summarize what we have discussed today. If you see 1 1 1 in the row, then perform C2 dash is equal to C2 minus C1 and C3 dash is equal to C3 minus C1. This is a common operation I am doing. Why? Because it reduces your time and thinking process. And if you see 1 1 1 in a column like this and you do R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R1, means you remove the first row from 2 rows. Here you remove the first column from 2 columns. This is a common operation I am doing, not that this is the only method. I am using this. Why? Because always if you use the same thing, your thinking time reduces and the process becomes faster. 80 to 90% of the problems will help you, and every problem you are using property depending on RHS. But many cases we will get this situation. In that situation, you can use this to reduce the length. And if elements are jumbled in a row, so suppose I have alpha, beta, gamma, alpha, and gamma, alpha, beta. You can see every row I have same elements. First row is alpha, beta, gamma. Second row is also alpha, beta, gamma jumbled. So what is a common thing we'll do? C1 dash is C1 plus C2 plus C3. These are the hints for today's problems. And practice. As many problems you practice, it will become easy. When you do this, every first column becomes alpha plus beta plus gamma. You can take it out. When you take it out, it will become 1, 1, 1. You will arrange this. Then you do this. That's what we have done. So all the problems what we have done today are important and interesting. Please practice them. So I told you, after you practice this, we'll go ahead with new concepts of determinants. That is, we have a long method, that is matrix method of finding inverse and solving the system of linear equations. Thanks for attending. Thank you.